Hey everyone, in this session, let's understand how can we scale any software system from 0 to million of users. This is a very fundamental session where we will understand each and every components we use in our system design. This session will be to understand overall system and their components. In our subsequent sessions, we will learn them in detail. Let's understand this whole session as if you are starting your software startup company. What you need? You need a very big idea so that you can help the mankind. Let's assume you have concrete idea, you have developed the code like a pro, your application is working absolutely fine in your system. What do you need now? You need to host the application. To hosting the application, you should have a web server. You don't know if your idea will work in reality or not. What you will do? You will obviously use a single server to host your application. Let's assume your own machine is working as a server. What you have on that server? In your server, you have web server, you have database and file system. Now we have server where web server, database and file system resides in a single machine, and this machine has an IP address. IP address is a 128-bit long number which is very difficult for a user to remember if the address is complicated one. Hence, we have something called URL. www.google.com is nothing but a URL. What user can remember easily. But our network system does not know about this URL. It cannot work with this URL. What we have to do? Obviously, there should be some converter which converts this URL to the IP address. Then only your user will be able to connect to your server. The system is known as DNS or domain name server. What it does? It converts the URL, which is www.google.com, to the corresponding IP address. So obviously your user opens the web browser and types URL in the web browser. The web browser communicates with DNS system and gets back the corresponding IP address of this URL. And finally, once IP address is available to your user can connect to your server via IP address. Hence, your user communicates with the DNS server to convert the URL to the corresponding IP address. That means what? That means your DNS system has that mapping. The mapping table has some abstract view, something like this, where you have URL and then corresponding IP address. Your DNS has this mapping table. What it does, as soon as a user connects to DNS along with the URL, it finds the corresponding IP address of this URL and it gives back the IP address of that URL. And finally, user communicates with your server with the same IP address. So now you are aware that how DNS system works, which is a very important component of your overall system design. In any of your system design interviews, you have to explain this if required. This works excellent when your startup has a very less number of users. Now, let's assume that your startup has grown up than before. This system will work, say, from 0 to 100 users a day. But as soon as number of users explodes, this system is bound to fail. Why? Because your server does not have sufficient space and the compute to handle a large number of users. What do you need? You need to scale up this server. Why we need to scale up? To handle the load, to increase the memory. Now, when I say memory, we have two different kinds of memory. One is primary one, another is secondary. When we want to handle a large number of requests, we need to increase processing speed. So basically, your server needs more RAM to increase the primary memory. you need more secondary memory. That means you have to attach larger disk or SSDs. You need to increase the processor of the system because we want to increase the processing speed. This process is known as vertical scaling of your server. Because the server machine is same, you want to increase the resources of the server. Apart from vertical scaling, there is another way to scale the server called horizontal scaling. Basically, this scale up the server can be done using vertical scaling or horizontal scaling. If we have a single server and we want to increase the memory and the processing capability of your server, we always rely on vertical scaling. If we want to increase the number of servers, remember in this case, in case of horizontal scaling, we are not increasing the resources of a single server. Rather, with the same money, what we are doing, we are buying additional servers of same or different type, and we will see how can we connect them together to serve a large number of users. So now you know what is vertical scaling and what is horizontal scaling. Vertical scaling, you have a single server, you want to increase the resources. Horizontal scaling, you have bought additional servers with the same money. We will see which one is better. Vertical scaling has some inherent problems. If your server goes down because of any reason, because of any failure, your application will not be accessed by the user. This situation is known as single point of failure. This is very important in your system design interview. You have to make sure that your system does not have single point of failure. Otherwise, it's not a sustainable solution, right? Your server will go down and your user will have bad experience with your application, and eventually your users will not have enough trust to connect to your server again. So vertical scaling works to some extent to handle your larger users, which is say 1000 users a day, but in long run it will not work. One disclaimer, all these values are assumed values. Based on your vertical scale, probably your system can handle more than 1000 daily active users. DAU is nothing but daily active users of your server. But if it is more than 1000 DAU, let's say, then your vertical scaling will not able to handle the load again. And remember, you will not be able to attach enormous size of disk and primary memory or RAM in a single server. It has some limit. We will see the calculations in our future sessions as well. But for now, let's understand that you cannot attach enormous size of RAM and disk in your system. There is a limit. After that certain threshold, you are bound to go to horizontal scaling. Now let's assume you have more than 1K users and they are very active in your system because your startup is growing up. Hence, we have to go for horizontal scaling by adding additional servers. So far, we know how DNS works and how we can scale our server as and when it is needed. Remember, these concepts are very important for any software system design. So, for horizontal scaling, we have no single point of failure. Even if one server of your system is down, there will be other servers who can handle the request. So with the help of horizontal scaling, we can easily solve the single point of failure risk what was there in vertical scaling. Apart from this, you have another inherent issue in this system. If your server is down, your database will also lose the data. Your file system will also lose the data. Why? Because a single server of your startup is responsible to save the data to process your business logic as a part of web server. In computer science, it is very important to have single responsibility principle. Your system either should handle only the data or the business logic, so that if something goes wrong in your business logic, at least your data will be safe. As per single responsibility principle, you should not keep everything in a single server. Hence, we change this design from a single server which handles web server, database, file system to multiple servers. One server will be responsible for web service, second server will be responsible for database, and another server will be responsible for your file system, for example. Now, in order to adhere to single responsibility, we have splitted the single server into three. One is responsible for web server. As and when it needs data from database, it will communicate with the database. As and when your web server needs data from file system, it will communicate with file system. And rest of the part is exactly same. So what will happen? Your user will connect to the web server, and your web server will communicate with the database and file system as and when required. This gives a lot of benefit. It gives security to your system as well. If your web server goes down, you can simply create another web server and connect the new web server with the existing up and running database and file system server. Now again, assume your startup is growing really fast. You are getting a lot of users every day. You need horizontal scaling, as we understood few minutes ago. In horizontal scaling, let's increase the number of servers. Earlier there was only one web server. Let's increase it to multiple web servers. Let's assume all of your web servers are communicating with the database server and file system. Now a big problem will arise. Think about this DNS. Earlier there were only one server. One server had a single IP address. It was very easy for DNS server to convert from URL to IP address, and your user as and when gets IP address, it can communicate to your server. What will happen in this case? Now you have multiple web servers. Let's say web server 1 and web server 2, something web server n. How this will work now? If you give only one IP address in your DNS, for example IP address of web server 1, then all your users will connect to web server 1 and rest of your web servers will be unused. Hence, we need a new component now called load balancer. What is the use of load balancer? Load balancer takes all the requests from users. Okay, let's assume this is your user and it communicates with the DNS as usual, gets the IP address back and communicate with your server. This time we will provide the IP address of the load balancer instead of giving the web server IP address. Why? Because we want all my requests should come to load balancer. Now the responsibility of load balancer is to distribute it to the web servers. So now you know what is the use of load balancer. As and when you have multiple web servers, you cannot give a single web server IP address to the DNS. If we do so, then all the users will connect to the same web server and rest all web servers will be unused. Hence, we introduce load balancer. Load balancer is another machine which receives all the requests from all the users and then it distributes the request to any of the available web servers. Now how it will distribute? We can have a number of algorithms for it. We have FCFS where we are telling, okay, as and when we get the request, you go to web server 1 first and then web server 2, web server 3 till web server n. Again, n plus 1th request will go to web server 1, something like this. This is also known as round robin algorithm. There are many more algorithms to handle or to distribute the load to the appropriate web server. Assume different configurations are there in different web servers. In that case, few of your web servers will be able to process more requests than others. your load balancer can be intelligent enough to provide more load to the web server which is capable one, and you can distribute less load to the web server which is leaner one, which has less resources while distributing the load. We will understand all these algorithms in our subsequent sessions, but for now you know why load balancer is needed in your system, why multiple web servers are needed for your system. You want to perform horizontal scaling in order to handle larger user base of your startup. Why DNS is used? To get IP address of a specific URL. To get the IP address of a specific URL. Hope so far you are with me. Now think about this system. You have multiple web servers. So if one web server is down, you have a number of web servers who can handle the load. What about database? You have a single database server which has two major cons. One, size is limited, because again your database server cannot handle enormous amount of data. After certain threshold, you cannot increase the capability of your database server. And as this one is a single server, it is a single point of failure. How you can solve these two problems of your database? To solve these problems, you have to increase the number of database servers. What you will do? You will have multiple servers now, DB1, DBN. That means you have to split the entire data into multiple databases. This process is known as sharding. Sharding is a process through which you can split the entire data into multiple databases. We will learn about sharding in our subsequent session. To handle single point of failure, to enhance durability of your database, we have to do something called replication. So, two important concepts we have to understand from DB perspective. One is sharding, another is replication. What sharding does? Sharding gives you flexibility to add data in one among n number of databases of your system. What replication gives us? Replication gives us durability of my data. Even if one database is down, we have some replicated database through which we can get the data back. In any case, we will not lose the data. That's why sharding and replication, these two are important concepts what we have to learn in our subsequent sessions. For file system also, we need replication. The reason is same. We don't want to lose the data. If we lose the data, our users will be disappointed and eventually lose the trust. And for your startup, trusted users are key for your success. What about load balancer? If you see, this is also a single point of failure. So for load balancers also, we have to do something called primary secondary model, where you will have one load balancer which is active or primary, and you can have other load balancers which are acting as backup. So they will be connected with your primary load balancer, and your secondary load balancer will always look the primary load balancer if it is alive or not. If your primary load balancer is alive, your secondary load balancer will not accept any request from user. As and when your primary load balancer goes down, your secondary load balancer will be upgraded to your primary load balancer, and the DNS will be updated accordingly, so that next time onwards, as and when user converts the URL to the IP address, it gets the new IP address instead of the failed load balancer. This is the very basic approach. Apart from this, there are more advanced approach to handle this single point of failure of load balancer, what we will learn in our subsequent session. Now your system is durable. Even if one of the components is going down, you don't have to worry. Your users will be served even then. Hope you are enjoying the concept we have discussed so far. As over the period of time, your system is getting more or more complex, the request processing time will be more here because it is adding up more network delay and communication delay among components of your system. Earlier, there were single server and there were no communication lag or network lag in your system. Let's see how we can make this system more performant now. Two concepts which are very important to enhance the performance of your distributed system like this. One is called cache. Second is called CDN or Content Delivery Network. We will understand these two concepts and we will see how these components will fit into the overall system to enhance the performance of the system. So far, you have users which are communicating with DNS. Once it gets IP address, it is communicating with your load balancer. Your load balancer also has primary, secondary or active passive setup where your secondary load balancers are here, which are checking always if the primary load balancer is working fine or not. If not, then it will immediately upgrade itself to the primary load balancer and update the DNS so that next time all the users will communicate with the new primary load balancer and your user will not be aware about it. So they will be relying on your system. We have multiple web servers, web server 1, web server 2 and web server 3. Your load balancer based on some algorithm will distribute the request to a number of web servers, and finally you have multiple databases as well. Multiple database servers will have data in distributed manner. Here also it can have a primary database and secondary database. We will understand about this sharding and replication in detail in our subsequent sessions. For now, you assume that you can have multiple databases to distribute the load, and also you have multiple file system 1 and the replicated file system as well, which are making sure that your data is not lost in any case. So far we know this kind of architecture. Now fetching the data from database server which is away from the web servers can add up the delay in your overall request processing. What we can do, we can add another layer in between web servers and databases where we can keep the data which is nothing but subset of your databases which are being accessed frequently. In other words, the frequently accessed data we can keep within another layer between web server and database. That very layer is known as cache. Let's modify the architecture. Here we have introduced a new layer called cache between your web servers and databases. What is the responsibility of cache now? Cache is a faster way to access data. What was the issue? Your database is detached from web server now and there is a lot of communication delay between your web server and databases. Hence, subset of data from database we can keep it in cache. Cache is a faster way to access data. What your web servers will do, as and when it is processing a new request, it will first check if the required data is present in the cache or not. If it is present, then it will not even communicate to the database anymore. It will take the data from cache and process the request successfully. In case the data is not present in the cache, because you can understand that your database is huge and your cache is storing only the subset of the data. So there could be some situations where the required data is not present in the cache. In such cases, our web servers will communicate with the database to fetch the data. If we get the data in cache, we call it cache hit. If the data is not present in the cache and web server has to go to database to access it, you call it cache miss. These two are the important metric to understand how your cache is working. What is your aim? Your aim is to keep only the frequently accessed data into cache so that the hit ratio will increase. If we see that our system is having more misses than hit, we have to review the cache and we have to modify the algorithms used in cache. We will take another beta strategy to increase the hit ratio. Hence, as and when we will introduce cache in our system, it is important to monitor the metric called hit ratio of your cache to understand the effectiveness of the cache. In our subsequent sessions, we will read more about cache. Lot of algorithms are there. We will understand them together. But now you know why cache is important in your system and what to check if you introduce cache in your system. You have to check hit ratio of your cache. Let's understand about CDNs now and where this component fits in your overall system. So far, you have users which are communicating with DNS, and then it is communicating with your load balancers. Your load balancer can have multiple instances to avoid single point of failure. Your load balancer distributes the load into multiple web servers. Your web servers is communicating with cache. Cache helps us to increase the performance of our overall system because accessing database every time can take more time. So we had introduced a cache in our system. If the data is not present in the cache, it can happen, right? Because you have subset of data in your cache. So there could be some required data which is not present in your cache. So you have to go to DB to access it. But in order to increase the hit ratio, we will always keep the frequently used data in our cache. How will we understand that which one is frequently used data? All these nitty-gritties of cache we will read in our subsequent sessions. Your web server is also communicating with file systems which can again have replicas. Why it is important? Because we don't want to lose any data. If one file system server goes down, at least we will have the data replicated to other file system server so that we can get the data back and our user will not lose any data. It will give more trust and our users will be satisfied. Now, where CDN comes into picture? CDN help to increase the performance of our overall system. How? CDN or Content Delivery Network, also known as edge server, are the servers which are nearer to the user and it stores the static contents like image, videos, etc., which are heavy object of our system and which are static. Those data we can keep to the edge servers or CDNs which are nearer to the user so that it will reduce the load time. So benefit is it reduces the load time of images and videos because the servers or CDN servers will be very near to the user. By using CDN, we are reducing the network delay. So now you know if you are connecting to YouTube to see some video, that video is not coming from the actual YouTube server. Probably the video is coming from a CDN or the edge server which is nearer to you, where you have the videos and you can fetch directly from CDN server instead of going through this long tail. So CDN is another component which is enhancing the overall system performance. Now you know what is DNS, what is CDN, why it is being used in a large distributed system where performance is the key. You know load balancer, how it is helping us to distribute the load among multiple web servers. We know why we need multiple web servers, why cache component is important in your overall system architecture, why replication of your data is very much important to make the data durable. With this setup, your startup will be able to keep the user's data safe. Even if one system goes down, you will not lose user's data. By introducing cache and CDN, you have enhanced the overall experience of the user by reducing the load time. Now, one last concept and then we will close this video, which is called data centers. The whole system resides on some physical place called data center. Data center is a physical place where we keep all our servers. There can be multiple data centers across the globe. Data center 1, data center 2, like this, data center n. They are usually geographically distant from each other. Now, if we keep all these components in a single data center, let's say data center 1, and because of any reason data center 1 fails, all your effort to design this whole system, which is complex enough, will go into vain. Why? Even though you have taken care of the system such a way that there will be no single point of failure, but you have kept all these components in a single data center, which is nothing but a building. What can happen? Power goes down because of any reason. Some natural calamity happened. For all these cases, your data center can fail. That means if you are keeping all the components in a single data center, even though you have replicated your data, even though you have replicated your servers or load balancers or databases, it will not work. Still you are prone to fail. Still your system is prone to fail. What we have to do is we have to increase the replication across data centers so that even if one data center fails, you will have data, you will have the web servers to serve your users. So replication across data center is also an important concept in any system design. Let's summarize what we have learned so far. We started from a single server and then we came to this large complex system to handle huge number of users in a day, also known as DAU, daily active users. If your startup has lot of users to handle, you have to come up this kind of system architecture to handle the load. You have to make sure that you will not lose any data even though there is a system failure. Your system is up and running even though there is a system failure. And finally, with the help of multi-data center replication, your system will be up and running even though the whole data center goes off because of some reason. Hope you have realized a step-by-step approach to enhance your system design and mitigate all the issues or concerns we were facing in each setup. Now the question is, should you come up with this kind of system design in the very first day when you are establishing your startup? The answer is no, because of two reasons. One, you do not have sufficient users to utilize this complex system. Number two, you do not have enough fund to create this kind of complex architecture. So if you are making a complex architecture, remember you have to spend lot of money and effort to make it up and running. Hence, system design concepts are not applicable everywhere. All these concepts you have to understand and then you have to intelligently identify the requirement of your system. You also have to be future proof in your system design so that it can be extended very easily. If you have learned something in this session, do not forget to like, share and subscribe. Thanks a lot for watching this video.